This project is completely focused on PySpark from the beginning to the end. We get the raw data, we assign the schema to it, we clean it, we transform it and make it business ready, and the final data will be connected to Power BI to create a dashboard. And here's the best thing. Every single tool that we use to complete this project are completely free. You don't need to spend a dime on it. And with that being said, let's begin. The project that we're dealing with today is retail analytics. We basically get the raw data and then transform it into a visual dashboard using Power BI, and that will be our final outcome. And this final outcome should present the total revenue of the company to see the growth of it and the seasonality of sales. We basically are going to create a revenue by time line chart or something like that to show the seasonality of sales. And also the overperforming and underperforming categories. We have to create a few charts that visualize these topic as well. And the final point that should be included is the regional sales. We are also going to create a few charts that visualize the regional sales, which helps any retail company to manage their inventory in that particular regions and also plan their strategies accordingly. Well, I'm talking about the example because this is an example project. And I have to mention this project is a follow-up for our last PySpark masterclass. So if you haven't watched that PySpark masterclass yet, I highly recommend you to watch that first and then come to this one because this is a follow-up. And this project is primarily focused on PySpark. And yes, I will leave the link of that PySpark masterclass in the description and also in the cards on top right corner of your screen. You can click on either of them and watch that first. And this is a blueprint of our plan. Basically starts with the data source. We're going to have a CSV file, .csv file that I created by my own. I haven't got that CSV file from any other source on the internet. So I created that .csv file, which basically includes 1,000,000 records. I will also provide the code for you. I used a Python code to create that .csv file. So you can actually manipulate how many records you want because 1,000,000 might be a huge amount for your PC to handle. So you can just cut it to half, like 500,000 records or even lower. It's up to you. I'm going to also give you the code to generate that CSV file. I will also say how to manipulate the file to generate that .csv file with the desired amount of records in it. So don't you worry, that will be our data source, that CSV file. Then that is our data source right here. And then we use PySpark to get the data from that CSV file and then assign a schema to that data because CSV file doesn't have a schema for that data, right? So we assign a schema to that data when we import the data from CSV file and then save it as Parquet file, which will be our bronze layer. By the way, we are going to follow Medallion storage architecture to process the data, which includes 3 steps: bronze, silver, and gold. Bronze will be the raw data, and the silver will be the cleaned data, and gold will be the transformed and business ready data. So in this bronze layer, we will store the raw data with the schema assigned to it. Well, the schema can be in silver layer or in bronze layer. Either way it works, but we are going to do that in bronze layer itself. Then with PySpark, we're going to get the data from bronze layer, clean it accordingly and make it gold layer ready, and then save it in the silver layer, and then pull the data out of the silver layer and transform it, make it business ready, and then save it in the gold layer. And that final Parquet files, we will use Power BI to connect to that Parquet file and then create dashboard from those files. That will be the whole flow of the project. Now let's get started. Before beginning with our first step, which is the data source, we are going to initialize the setup first on our PC. And the setup is so easy. It is so simple, and also all the tools that we are going to use to complete this project are completely open source tools, which means free. You don't have to spend anything on any of them. And the first one we are going to install is Docker Desktop. And Docker, to install Docker Desktop, you can go to your web browser and search for Docker Desktop. And by the way, if you already watched PySpark Masterclass, you don't have to watch this part because you already know the installation part. So I'm going to do the same installation part for PySpark. So you can just skip this part and go to the next step. Okay, and this is just for the people who are watching this video first instead of watching PySpark Masterclass. So here you can just click download right here, or click on this link, the first link, and go click on choose, no, not choose plan. Click on download Docker Desktop and choose your particular PC specification here, and then download it. Or else I'm going to provide the link as well in the description for the Docker Desktop. Okay, we need that. Let me open that. Now, after installing that, after downloading that file, the installation file, you just have to install it with the default settings for everything. Just click on install, continue, and install. That's it. And you also don't have to sign up for an account. You can just open it. You don't have to sign up, and this will be the home page that you will be landing on. And whatever the containers that we are going to create to install Apache Spark in our PC will be visible here. And we are going to create like 3 containers. Now let's see how we create that. We first have to create a repository for our project. And to do that, I'm going to use PowerShell for that. Open PowerShell and name it retail PySpark. Enter. If you haven't used a CLI before, just a quick, I'm going to just give you a brief introduction about this. What I just done is nothing but creating a folder in a particular location, and the location will be this, the C drive users, and this will be your username. Here, this is my username, and on your PC, that will be your username. In that location, I just created this folder. That will be our project repository. We will be working in that repository throughout the whole project. And in that, I named the repository, the folder, as retail PySpark. And mkdir stands for make directory. And now we are going to use cd retail PySpark. cd stands for change directory. Now, whatever I run after this will be reflected to this location, retail PySpark. Now let me minimize that to folder, users, C drive users, and the username. And here we can actually see the folder that is created, that we just created, that is empty right now. Now what I'm going to do is open VS Code editor. This is not mandatory for the project. This is just for the readability of me and you, because I'm going to explain the code that I'm going to write. So this will be a perfect, a code editor to explain the code. And that's why I'm using this. This is not mandatory. You can use Notepad itself. That's the same thing. Click on that and click on open folder and choose the folder, choose the repository that we just created, which is users. Yes. And I'm also going to pin that repository to quick access. So I can just access the folder from here itself. Okay, that's good. Now here, we're going to run the Docker Compose .yml code, which has everything to initialize the containers to actually install Apache Spark in Docker. To do that, I'm going to create the file, name it docker compose.yml. Now minimize this. I already have that file written, and I will also be providing, you can also get this file and all the coding files that I'm going to use in this project from the GitHub link in the description. I'm going to copy this, paste it in VS Code, little bit. Now what I'm doing here is I'm creating 3 containers, 3 services, which includes Spark Master, Spark Worker 1, and Spark Worker 2. Firstly, talking about Spark Master, we all know Apache Spark needs a cluster manager, the architecture. Basically, the actual architecture of Spark is a cluster manager, a driver, and multiple workers. It can be single or multiple workers. And the cluster manager here is named as Spark Master. This is a cluster manager. The main functionality of cluster manager or Spark Master is to provide resources to the driver to run the code, to run the jobs. Here I used image and the Spark version 3.5.1 and the container name. This is the container name. It can be anything. And the host name Spark Master. And here, just close this thing. And the bash command to run the master. And then these are the 2 ports. One port is for the UI. This one is for the master UI. We use master UI to control the workers that are connected to the master, and also to control the Spark sessions that are connected. We can kill them, or we can actually monitor them using the UI. And then this is the port that we can use basically as a listener port to connect to the master. And then these are the volumes that we are initializing to the container. Basically, when we write a Docker Compose file, we have to, if we want to have that container have access to any of the folder on our PC, we have to initialize them as volumes. And here, because I saved this Docker Compose file in this project repository, retail PySpark, here, this is a reference folder. And this will be how we can refer to that app folder. Right now, we don't have app folder here created, but when I run this compose file and create those containers, Docker will do that for us. Docker creates those folders that we initialized here, or else we can create them. They will be overwritten anyway. So this will create 2 folders, one named app and the other one named data. And these are with reference to them inside the Docker containers. Basically, we are not going to use app, but we are creating that volume as a backup for now. We only going to use data to store all our data, the raw, bronze, silver, and gold data, everything in the data. So we can transfer data from the containers and the folders back and forth. And that's why we initialize that volume there. And the next one is Spark Worker 1. basically the same version, and the container name, host name, and then use this to initialize it and connect to the master using the port master 7077. And it has two ports. One used to connect to the worker, and the other one is for the UI, because we are going to use this worker as the driver as well. We haven't initialized any separate container to act as a driver, so we are going to use a worker as an executor and also driver at the same time. So we're going to, when we initialize the Spark session, we define this worker as the driver, and by using this port, we can access to Spark UI. And it depends on Spark master, obviously. And then we initialize two volumes, so the workers have access to it to store the data, because the workers are the one who executes the code and does the manipulation of the data wrangling stuff. And that's why the workers also have to have access to those two folders. And then Spark Worker 2. It's the same thing, same replica of Spark Worker 1, but the only change here is it only has one port, which is the listener, to connect to the worker, but not the UI, because we only need one driver, and Spark Worker 1 will act as a driver and executor. We don't need Spark Worker 2 to act as a driver, so it only have one port. And it depends on Spark master, and these two volumes are initialized. And that's it. This is the Docker Compose file that we have. Now we are going to use this to turn the containers up. To do that, we can use any CLI. We can use PowerShell, or Docker itself provides us a terminal to run our code. We can use this as well. Now I'm going to use PowerShell. That should be good. Now we have to run from the, by the way, we have to run this command from the location where we stored that docker compose.yml file, and we stored it in the project repository, right? Yes. So from here, you have to run docker compose up and -d. So this will turn the containers up, and the -d flag refers to the detach. If you don't use that, this terminal will be dedicated to show the logs of that containers. So that's why we use -t at the end. That is not mandatory, but that can be used. So this is the actual command to turn the containers up, and to turn them down, we just say docker compose down to turn them down. So we have those containers. Now when we open Docker desktop, we can see all those three containers created here: Spark master, Spark worker 1, Spark worker 2. And like I said, Spark master has two ports. One acts as a listener, and the other one as UI, which is 8080. When we click on 8080, it is connected to two other workers, which we initialized, and both the workers have 2 cores each and 2 gigabytes of memory each. And this is the address for those workers. Minimize this, and here we can see the running applications if we run any of them. We haven't run any applications. This is where we can see the complete application when we close the application. We haven't run any, so there are none. We are going to create. Now, right now we cannot access 4040 because we haven't defined this worker as a driver to any application yet. Okay, now we have the setup ready. So that's what we want. Now close that. Plan. Now we step into our first stage, which is data source. We're going to create the data source instead. Let me show you. I also have the code for that, which is this one. So you can find this code in the GitHub repository, by the way. And this code is used by me to create the CSV file that I have with me. Or I'm going to show you how to create this CSV file as well, and how can you change the number of records that you want in your CSV file. So before we go further, we have to know about the data, the base data that we are dealing with, right? And this is the data that we are dealing with. Firstly, we import the modules that we need. This is just a plain Python code, not Spark, not PySpark. Okay, and these are all basically, this is the output file name and this is the number of records. So when you run this code, it automatically creates a million records in that .csv file. So if you want to turn the threshold down or the volume down, you can just manipulate this or change this like to 500,000 or 250,000 or even lower than that. Right now I just set it up to a million, so it creates a million records. Ignore all about this. This is all about saving the file in the directory. And now we create a list of cities with its state as well. So it has a list of tuples basically, and each tuple has a city and the state of that city. New York City, which belongs to New York State, and Los Angeles, which belongs to California State, and Chicago, Illinois, Houston, Texas, basically most of the states in US. And then the categories include electronics. Categories is basically a dictionary with values as tuples, and here we defined as categories as electronics, fashion, grocery, furniture, sports. And for furniture, this particular tuple, I defined this to actually manage the range of the price difference between the electronics products. And here electronics varies from 100 to 2000, and fashion from 20 to 500, groceries from 1 to 50, and so on. And then we have payment types. By the way, because I'm creating the data, there is no way we get any fault data in that .csv file, in the raw data. And basically cleaning that data, that doesn't make any sense because the data is already clean because we created the data. So what I did is I intentionally created the code file to actually ingest some errors into it, which includes payment types. When I define this payment types list, I say card, UPI, COD, crypto, none. So we only need card, UPI, and cash on delivery, COD. We don't need crypto. Crypto will be a fault data. So I'm going to remove that. We are going to remove that in the silver layer transformation. And then the same thing with the genders. M and F will be passed through the silver layer, and the rest, male and female, will be taken out, will be considered as fault data. And then order status has nothing, no fault data in it. And the start data, I just defined a variable start date, saying start date time of 2023 1/1. This is the range, is the time bracket that we are going to use in that CSV file. So all the orders are placed in between these dates. You can also configure this if you want your data to be more diverse in the time frame. You can just say, expand the time bracket here, and this is the end date the same way. So it starts from 2023 January 1st and to 2026 January 1st. And then we define a function to pick a random date, and the function name is also defined as random date of start and end. Delta will be the end date minus the start date. So it gets that the delta between the start and end, the time, which will basically be 3 years in our case. So what it does is it returns start date plus the time delta of day of random dot rand int of. So it picks a date from start, between the start and end, a random date, and then a random time delta, and adds that to the start date, which will be any date, any date between these two uh, dates, the start date and the end date, in between the bracket. And that's how we use random.randint of 0 comma delta dot days. So it picks a random day between this time bracket. And then we have this with open file path. So it opens a file path, and mode write, mode W, which is write, and it writes the CSV file using writer equals csv.writer of file. And because it's a CSV file, the first row should be the headers of each column, right? And that, so we use writer.write row, and the first row will be the column names, which includes transaction ID, order ID, ship date. Now, order date, by the way, not order ID. So the date of the order placed, and the ship date, the date when the order shipped, the customer ID, the ID of the customer placed the order, customer age, the age of the customer, gender, product ID, the customer actually ordered, and then product category, the category that product belongs to, quantity, number of products that particular customer ordered, and unit price, the price of that product, and the discount percentage. The discount PCT basically refers to percentage. It shows how much discount is applied to this particular order. That is discount percentage, city of where the customer lives, and the state that city belongs to, and payment type, customer used, order status of that customer's order, and ingestion date, basically when this record got ingested, which will be the present time when we run that code. Now for I in the range of, so we use a loop here, and then it iterates until the number of records got satisfied, which means 1,000,000 records. So it iterates through 1,000,000 times until the CSV file gets generated. Then it picks a random integer for the transaction ID, use random.random integer to pick a random integer between 1 to the number of records, which is 1,000,000, and then it uses float division to divide that by 2, which is basically dividing 1,000,000 with 2, which will be 500,000. We use float division to deal with the decimals. If it is a number that cannot be that can produce decimal number when it is divided by 2, it will be floored to the lowest next integer. The order date, random date between the start and end date. We already defined the random date function right here. So it picks a random date between the start and end date. Ship date will be order date plus time delta of days equals random dot rand int of. So this basically adds a few more days, a random number of days to the order date to actually assign to the ship date. And here we're going to ingest a few false data by using a negative number of days, which means this will assign a past date from the order date to that ship date, which will be a false data, right? And then customer ID, it randomly assigns random.randint of 1 to 2,000,000. And then customer age, this will also ingest some random data, which includes negative age, which doesn't make any sense. We're going to ingest that data, and also rand int of a random integer from 120 to 200, which exceeds the actual average age uh, of a customer. Gender equals random choice of gender. We already ingested the errors in it. And category, random choice of list of categories dot keys of. So it picks a random category, and price minimum, price max. From that category is the dictionary that we defined before right here. So it picks a random price from that as well. And then city state, random city state for every single record. And that's how I initialize that. I define the data for that .csv file, which is our data source. Now the data, the .csv file that we get when we run this code has multiple fault data. Yes, and the fault data columns will be the transaction ID. We did ingest errors in transaction ID because we divided the number of records by 2. So half of the records will be, the transaction IDs will be repeated again. And the transaction IDs should not be repeated. There should not be any duplicates in transaction ID. That will be a fault data. So we ingested transaction IDs, fault data, and payment types, because we used crypto in the payment types. That is a fault data too. And then genders, like I said, it should be M and F. We replace this with one type later, so that also considered as a fault data. And then we have ship date, which will be in which few records have past ship date compared to the order date. So that will be the fault. And the age, which exceeds 120 or 100, and negative age, that is also fault data. And price, we also included negative pricing, that will be the fault data. And the quantity also has negative values in it, that will also be considered as fault data. And at the end, last one is discount percentage. We did included like 130% discount in it. Let me see. Oh, where did we discount percentage? Right here. So we use random.uniform of 0 to 50. This is valid. This is valid, okay? But random.uniform of 60 to 150. So it can be 110, 130, or 140. That doesn't make sense. So anything exceed 100, or anything exceed 100% discount should be considered as fault data. So these are the columns that we are ingesting fault data into. Now, let's see how we create the file. Now I saved this. No, I haven't saved it yet. I'm going to copy it. Now, first I have to create the file. I have to create the file and say, name it. Generate raw data .py. And here, I'm going to copy paste the code into this file. Now open PowerShell. Here run Python. And the name of the file, copy the file name, paste it, .py. Run it. Now this will create a .csv file in, the location, output directory should be this. So it will create a .csv file in data folder under raw folder. This will be the CSV file. Let me open that. So these are the records that we got in that CSV file. See that transaction ID, order date, ship date. We have everything we need here. Okay. Let me close that file. And yes, if you want to load the number of records that you want, you can just change this number, the number of records, and then you get that desired number of records in your .csv file. Now, with that, we're done with this stage, the data source. Now we have to head to the next stage where the actual PySpark process begins. We pull the data out of that data source and then store that in the raw, the bronze layer of Medallion architecture. Let's go for that. Now for the next step, we're going to open PowerShell. Let me zoom it in a little bit. Okay. That's good. Now here, let's open up a PySpark session, and then we can write the PySpark code and clean the data. Because the containers are running inside Docker, we have to say Docker execute it, and then here we define the driver, which will be our Spark worker 1, which will be acting as a driver. So we say Spark worker 1 here, and then we use that bash file to open a PySpark session, and then we define the master. Like I said, I'm just explaining everything briefly to the audience that are just watching this video first before watching PySpark masterclass, and that's why I'm explaining every line again. Well, I already explained these lines before in the masterclass itself. Then now connect to Sparker using the port 7077. Run it. Wait. Okay, I see the error here. So let me just copy this line again, because I cannot type that again. So I'm going to copy that, paste it here. And there is one hyphen missing here. Should be 2 hyphens, master. Copy, paste it, run it. Now that will create a Spark session. Now when you go to the master UI and refresh that web page, you can see an application getting created because we just opened an application, the Spark session, the PySpark session. Now go to the Docker desktop and click on this port 4040 because we just created the application. We can be able to access to Spark UI, and this is it. Now whatever we run, we can monitor the jobs and stages that are getting created in this UI. Well, we are not going to dive deep into this backend of Apache Spark because we already talked everything about it in the masterclass, and we cannot talk about that in this project because this project, I don't want this project to be lengthier. I want to keep it simple because this is for the people who just begin with the PySpark, and yeah, I want to keep this simple. So I'm not going to go deep into the core of PySpark, the core of Apache Spark. Okay, now our bronze stage, which will be assigning the schema to the data by pulling the data out of the CSV file and then storing it as a Parquet file in the bronze stage. Let's do that. For that, we need and we also need date type. Now we need these modules to be imported because we need struct type to define the structure, the whole structure, and then we need struct field to define an actual field. And in that field, we need these types, these data types, integer type, string type, double type, date type to define the date that that particular column has. We need integer type to define the column that has integer data types, and string for string data type, double for decimal basically, and then date for date data type. Run that. Now we have the imports ready, and for the schema, we start with, I'm going to start with a parenthesis or an open parenthesis, and then struct type. This is to define the whole structure of the field, I mean the whole structure, and then struct field of transaction ID, which is our first column. That will be integer type. It depends. It can be integer type or string type. It depends on you. You can define it as your wish, but I'm going to take it as a integer type. Well, we don't do any mathematical operations with it, but still, in few places they use integer type to it, and in few others they use string type to it. Then if we take a look at the data, or the other columns that we have, the next column is order date. So I'm going to copy this part because we are going to use it a lot from now on, and say the next one is order date, which is date type, comma true. And well, this part is the data type of this column, but this here defines that this particular field can be nullable. Struct field again. No, I don't know, I copied that. Okay, let me just copy this again with the code, paste it. The next field is ship date, which is also date type. true for that. Paste it again. The next one is customer ID. Well, customer ID cannot be integer. Mainly because we designed the customer ID to have strings in it. A string in it, which is where it is. Where is it? Price, gender, customer. There you go. So it has cust. So it has string in it. So we cannot say integer type for that. So we say string type. We assign string type. True, comma. Paste it again. And the next one is gender. Should be string as well. No, the next one is not gender. The next one is customer age. Which should be integer. Integer type. True. Paste it again. Now gender, which is string type. The next one is product ID. String type. And the next one, product category, which is also string type. I'm going to copy paste that. String type and true. Copy that. Double quotes. And the quantity, which is integer type. So I'm going to copy paste this line. Then we have unit price, which is double type. So because that can be a decimal, we say double type, true, comma, and then we have discount percentage, which is also a double type. So we can just copy paste this. And then city, which is string, comma, and this part. And then state. I'm gonna copy paste the whole line and change this from city to state. Then we have payment type. So we can do the same thing with that as well. payment type. Same with the order status, and yep, let's do that. Order status. Now for ingestion date, that should be date type. So we can just copy paste this one. And then close it with a square bracket and a parenthesis. Is it 1 or 2? I think we need 2 parentheses. Okay. Oh, I spelled it wrong. On this line. Okay, we just copy paste that, I guess, into a notepad. So here I said I spelled it wrong instead of integer type. Okay, I took out the extra 3 dots that are copied, and now I'm going to paste this again and run it. Run it. Now that is defined. The schema is defined, but we haven't connected that schema. I mean, assigned that schema to the data. Open that. Now first we have to read the data. To read the data, say bronze df equals spark.read, and then dot option of header equals true. Because it's a CSV file, the header will be the first column, obviously. So we're going to say header is true, and then we say we assign the schema to it that we just defined. We define the schema with the name bronze schema. We're going to copy, paste it here. That will assign the schema that we defined, and then say dot CSV. By the way, we just ran the file. No, sorry. Yeah. From here, we have to access the CSV file that we stored in data under raw folder. Well, if you remember, we already defined the volumes to assign to the container, so the container have access to it, right? And those volumes are app and data. So Docker containers have access to data, and to address or to navigate to that address, we have to use this path. Remember, opt/spark-data. From here, we say opt/spark-data /. Now from here, we have to go to raw, and under that, retail sales raw.csv. Raw / and copy the name of this file. Close that. Here, say .csv, quotes close, parenthesis close, and another parenthesis to close. Do we need another parenthesis? I don't think we need another one. Okay. Now run it. Now the data is assigned to this variable bronze underscore df. So it is now assigned to this variable as data frame. Now we have the data frame in PySpark, but we can confirm it by using, let's say, bronze df, which is our data frame, and say count of, run it, counts all the records, and it says 1 million. So it does have the count correct. Now let's print the schema as well, because we assigned the schema. Let's see the schema is assigned in the right way to the data frame. To run that, say bronze underscore df dot print schema of. This will print the assigned schema of that data frame. There you go. Now we just check the schema, if the schema is correct or not. The transaction ID is integer. Obviously, we did assign that. Order date is date, ship date date, and all of them have nullable as true. And this schema looks is accurate to what we defined, which basically confirms we are almost done with the first stage of Medallion architecture, which is bronze layer, because we assigned the schema to the data. Now we have to write the data as a Parquet file with the schema. Let's write that using bronze underscore df dot write dot mode of. We use overwrite of, quotes close and parenthesis close, and then dot. The format, which is Parquet, open parenthesis, and here we define the path to save the file. We're going to use this part of the path to go there, and then from here we create another folder for bronze layer as bronze, and then we name this file as retail underscore sales underscore, and say bronze dot PARQUET, Parquet. Quotes close, parenthesis close, run it. Now this will create a Parquet file. Not one, because this data is processed with multiple it is partitioned into multiple partitions and then executed. This will generate multiple Parquet files. When we go to data under bronze, we can see multiple Parquet files and their corresponding .crc files for every single Parquet file. Let's see, extend it. Yeah, there you go. So we have 4 Parquet files. I think we have 4 partitions. Let's see in the Spark UI. Refresh. So this is the read. There you go. We have 4 partitions for this job. 4 partitions, and each partition processed like 250,000 records, and that is the reason why we have 4 separate Parquet files, and every file has .crc file for them. There you go. Now we are done with the bronze layer. Now let's head to the silver layer, the cleaning stage. Moving on to our next layer, which is silver layer. Let's get right into it. Now let's start by importing the modules that we need. From PySpark.sql dot import call, comma, when comma trim. I think that's it. We need this. Bronze underscore df. We're going to read the data from the Parquet that we just saved in the bronze layer and then assign to the variable named bronze df, which will be the bronze data frame. Spark dot read dot the format is Parquet of, and the path to read is this, the same path that we defined before. Close the quotes and close the parentheses, run it. Okay, I did something wrong. Bronze df read Parquet. Okay, now the error is here when I copied the path which is a .csv path, not the Parquet path. That's the mistake I've done. Now what I have to do is I'm just going to copy until this, paste it here, and then copy the actual Parquet path, which is bronze retail Parquet. And then paste it. Now run it. That is executed. Now, beginning with the data cleaning, we actually know the faults that our data has because we created the data, the data set. But if we actually dealing with an unknown data, we don't know what the faults that data has. Yes. So I'm going to write the cleaning code, but before every cleaning part, I also going to write the code that we use to actually detect if that data set has that particular fault in that. For example, first we are going to deal with the deduplication of transaction ID. Remember, we did included duplicates in the transaction ID, so we're going to remove that. To check if there are any duplicates in transaction ID, what we can do is we run that. Now what this does is it groups by the transaction ID, so the rows, the records with the common transaction ID will be grouped up, and then we count the records that particular transaction ID has, and then we filter we filter with the column count and say it should have greater than 1. So now this prints the first 5. So we say dot show of 5. So it prints first 5. I mean, any 5 records with the same transaction. I mean, which has more than one copy of transaction ID. Now, when we run this, there you go. So these are the examples, samples of the transaction ID that does have multiple copies of them. So this shouldn't be happening in when you work with the real data. So you don't want to have duplicates in transaction ID. So we have to deal with this. We have to drop the duplicates. So to drop the duplicates, we say now this will drop all the records that have duplicate transaction IDs. It only uh, keeps the transaction at the first transaction ID record, and the rest duplicates will be taken out. Now when I run this and then run silver df dot count of, you can see the number of records that survived the deduplication. Initially we had 1 million records, but now we have 432,512 records after filtering out the duplicates. That's the first step. We're done with cleaning the duplicates by transaction ID. Now we go to the date corrections, which includes correcting the shipment date, the shipped date. To find the errors in the ship date, what we can do is say order date. Show of 5 records. Now what this does is it filters out by the column ship date and say the ship date should be less than order date, which are actually the fault data, because the ship date should be in future compared to the order date. Anything in the past should be considered as fault data. Now when I run this, what I think I have to close the parenthesis. No, all right. What is that? Okay, the problem here is the placement of the parenthesis, the close parenthesis. It is supposed to be closed here and then run it. Okay, now we got the output. Let me extend to actually see that. Yep, I think now you can see that. Now this will show the ship date right here, which has the past date compared to the order date, where here the order date is 4 for this record, and here it has ship date as 3, which is fault data. And in the same way, this has 1122, and the ship date has 1120, which is a past date, So these type of records should be taken out. That is how we check for the date false. Now we create another column in the silver data frame, silver DF data frame. Say silver DF with column, and name the new column as ship underscore date. When of call of ship underscore date. Well, we are not creating one, we're just modifying the column and then assigning the new dates to it, the cleaned ones. When call of ship date is less than call of order date, the same logic we used when we checked the fall data. So we use the same logic here, and then replace those fields with the ship date less than the order date with none. We don't want those records taken out because we already taken half of the records out because of the transaction ID. So we don't want these records out. So we just replace that fall data with none. And otherwise, the rest of the data should be the same data which ship date has. Okay, now what it is. Says invalid syntax. I'll copy this again. So the error that I committed this time is I haven't closed the parentheses in a few parts where here and also here at the end. So I'm going to copy paste it again and close those not the parentheses, quotes. I mean quotes. Close those quotes. Run it. Run it. Okay, now that is executed, which means the error should be fixed. They are replaced with none values. Now the next fault data will be the quantity. We have to make sure none of the records have quantity less than or equal to 0. Yeah, because these are all transactions. If there are no quantity of products ordered, it doesn't make sense to have a record for that. So we have to filter that out. To find them, we can use silver DF or we can use bronze DF, either one. Filter, quantity, which is less than or equal to 0, show 5. Now run this. Okay, it did pop up with 5 rows, which means it does actually have that fault data with the quantity as less than or equal to 0, which is this. So it has -1, 0, -4, 0, -5. So this has to be cleaned. Zoom that again. Now to clean them, say silver underscore df, say silver df, filter of column of quantity greater than 0, So this will filter all the columns with only the quantity as 0 and the rest will be taken out. Run that. Syntax error again. Okay, yeah. I typed in an extra parenthesis at the end. Run it. That worked. Now the next thing is the unit price. We also ingested the unit price false, but now we have to first find if the data has the unit price false. To find that, we say silver df filter off call unit price less than or equal to 0 dot show of 5. Run it. Yep, we do have that fault data as well. Let me zoom that out. Okay, where is it? There you go, the unit price. It does have the negative values, which is not supposed to be having. Now to filter them out, we can do silver underscore df silver and say replace the column using width column of unit price. So we are going to replace this column in the data frame with the filtered data. Then of call. Not going to unit price of less than or equal to 0. Not going to filter them out. We're just going to replace them with nonce. So we don't lose any extra records for that. Let me shorten this. Otherwise, of call unit price. So if there are any fields that has the unit price that is less than or equal to 0, replace them with none. Otherwise, just keep the values of the actual unit price as is. Now, did I close the parenthesis correct again? So this 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Correct. There you go. Now the next one is discount. We did do the discount which is exceeded 100. So there should be a few records that exceed the discount percentage of 100, which is not, it doesn't make any sense. So we have to filter them out as well. So to find that, what we can do is to find if our data has the discount values that the value that is greater than 100. PCT is greater than 100. Did we ingested the data to also have negative discount? 0 to 50, 60 to 150. So we did not ingested the fall data to have negative discount. So we don't have to check for that. We just check for the discount that exceeds 100%. Dot show off 5. Run it. Okay. Now minimize the zoom out. Discount percentage. So we do have the discount percentage that exceeds 100. It has 114, 113, 120, 115, and so we have to filter them out. This doesn't make any sense. Now let's say silver df equals silver df dot width column of discount PCT percentage less no percentage greater than 100 space for that, none, dot otherwise of call discount percentage quotes close, parenthesis close, and another parenthesis, I think. I did put some extra parentheses, closing parentheses. We don't need them. One here and one there. Then that's it. And one more parenthesis to close this. Run it. Again. It says with column missing one required positional argument, call. Let me type that in again. I think I did a lot of syntax errors in that. So I'm going to write that again, type that again. Column with column of discount PCT, comma, when, say when, and then call of discount PCT is greater than 100 of, we close that parenthesis, 1, 2, 3, 4, 1, 2, okay. Comma, replace them with nones and close another parenthesis. Then otherwise call of discount PCT. Run it. There you go. Now that is done. Dealing with the next fault. We still have 3 more faults to deal with, by the way. The next one will be the age, which are I think we have the ages under 0, and also we just filter out the ages that are under 15 and over 100. So let's check them first using silver df dot filter of column of customer age is less than 15, or customer age greater than 100 dot show off 5 records, which will be the sample data. Now this does have the data with the age. Where is the age? Gender, product ID, age, shipment. Customer age. So there you go. There are 132, 142, 194, 138, 5. So we have to filter them out. Let me zoom that in again. Okay. Now we deal with that using silver underscore df dot with column customer age all of customer age less than 50, or call of customer age wait, let me just close this and then copy this one again and paste it here and say 100, comma, replace them with none values. Otherwise, say call of customer age. Run it. Run it. So that is clean. And now the next fault is the gender. Now what we're going to do is find there are faults in that column. We say group by gender dot count of dot show off. Run it. Oh, I spelled it wrong. It's supposed to be L silver underscore df. Run it. There you go. So this groups the gender. So the unique genders will be grouped together and the count will be shown. So there are these many types of genders. There is F, which basically indicates female, and then null, female, and M and male. So we just have to shorten them to F as female and M as male, and not two types, F and female and M and male. So we have to change that. So there are only two formats and there are null values. And so the female should be indicated as F and male should be indicated as M and not the whole word male. So to do that, we say silver df equals silver df dot with column of gender, comma, then of upper of call of gender upper of gender equals male, then replace it with M, close parenthesis, and when the same thing, I'm going to copy paste this part. So we're going to do the same thing with the female as well. Female, switch that to F, and when of call of gender is in. So we check if the gender is in this tuple, basically. So it should be either just the alphabet M or just the alphabet F. In that case, just leave them as is. Okay, and then now any other cases, replace them with none. This should do. I don't think I counted the parentheses correct. I opened parentheses here, opened one here, 1, 2, 3, 4. So I closed 2 and 1 here. So I closed 3. Here opened 3 again, closed 2 again, 1 here, and I think I have to close one more here. Run it. Now. Okay. Upper is not defined. Did I not imported that module? I think it should be somewhere here. Okay, I did not import that module. Okay, I have to import that as well. I have to import upper as well. Run that. Now copy paste this again. Now that runs. So that is done. So the next fault we'll be dealing with is the payment type. Remember, we included an odd payment type, which is crypto. We have to get rid of that. To see if there are any payment type faults, we can do it like this. Filter off. column of payment type is in card. What are the other payment types? Card, UPI, COD. UPI, COD. Show of 5. Oh, wait. We don't need those columns. We have to we have to filter those columns out and check if there are columns that are not card, UPI, or COD. So to say not, to implement the not logic, we just say in the filter, we just use this, no, that, run it. Now this will show the records that has a different payment type than the one we mentioned here. And by the way, I converted this into a not logic just by using this symbol. This usually is the button on top of the tab button, which which we have to hold the shift and then click it. So we have to use that symbol, that is the not. So it basically does the opposite of what we just defined here. So it picks up which is not card, UPI, or COD, which will be crypto. That's why all the cryptos are printed here, the payment type as crypto. Okay, so that's how we find the errors in the payment types. Now, silver DF, now we need to clean them out with column. Payment type. When of call of payment type dot, I'll copy this thing, is in these three, then leave them as is. Payment type. Otherwise, in any other cases, replace them with none. Then one more parenthesis, run it, another parenthesis. Okay, we did got another error here. Otherwise, can only be applied on a column previously generated by one. With column when, okay, I see the error here. I keep getting these errors with the parenthesis all the time. So here, I forgot to put an other parenthesis here to close that right here. Now, run it. There you go. So that one parenthesis is what caused the error. Now lastly, we write the data in the data frame. So you use write dot mode as overwrite of dot Parquet, and the file path will be, have to type in again. I cannot go all the way up to copy that. I have to type in spark data slash in silver folder Parquet, run it. Now this should save the data in silver folder. There you go, 4 Parquet files and 4 CRC files, coding for one for every Parquet file. And that's it. With that, we're done with the silver transformation as well. Now we have to head to the gold transformation. Now, time for our last layer, which is the gold layer. Let's do that. Let me open the PowerShell again. For this, we obviously start by importing the modules that we need, which includes we need to call sum count average round. Now we read the data that we just saved in the silver layer, assign it to silver df. Oh, my bad. Parquet off, and the location that I just saved the silver file is at this. Copy paste it, run it. Now we got the data here in the data frame. Now what we have in this data frame, okay, we have, what are the columns that we have? We have transaction ID, order date, ship date, column ID, column age, customer age, gender, product ID, product category, unit price, discount, city, state, payment type, order status, ingestion. Well, I'm going to create one extra column into this data frame which shows the total amount. That means calculating the final price after the discount is emitted from the price of the product. Let me show you how. Let me zoom this in. With column. So we create a new column named total amount. we multiply the column quantity to the column unit price. Then we get the actual, the actual total amount without the discount emitted. Now, to emit the discount from that, and then round this to 2. Now here, we are creating a new column which is named as total amount, which will be the quantity column multiplied by the unit price. So the quantity times the price will be the total amount. And now we have to, what we did here is we say column of discount by 100, because discount percentage is in the number integers. Now we divide that by 100 to get a point value, decimal value. That will be anywhere from 0 to 1. Yes. And then that will be the discount percentage. But to get the actual price, that the total amount that the customer the customer paid, will be calculated if we minus that point value, the discount pointed value, decimal value, with 1. I'm not sure if I explained it right. Product-based performance metrics, and then the next one will be the regional sales. So we create 3 Parquet files from this. Now for the first file, then the next line I'm say round off sum of total amount, comma 2 dot alias total revenue, comma count of transaction ID, alias total orders, round off avg of total amount 2 dot alias avg underscore order underscore value, and close that with double parenthesis. Run that. Now what I did here is I created our first data frame, which we are going to convert into a Parquet file. From the silver silver underscore df data frame we have, what I did is I grouped by the order date. So it groups by every day, and then I aggregated the rest of the three columns. I mean, not the rest. I aggregated three of those columns, which includes round of, sum of, total amount. So sum of total amount for the grouped order date, it sums all the total amounts and it rounds up to 2. And I aliased it as total revenue, which will be one of our outcome matrix that we need. And then count of transaction ID. So this counts the number of transactions, which means total orders on that particular day. Yes. So that will be our total orders on that particular day. And then round off average of total amount and round it to 2. And we take the average order value as one of our matrix too. And that will be aliased as average underscore order underscore value. Now we convert this, we write this as a Parquet file using slash opt slash spark data. And we're going to create a new folder which is named gold and name this Parquet file as daily sales matrix dot Parquet. Close the quotes and close the parentheses, and that's it. Run it. Let's check that file out. Under data, gold, we did got it. Okay, so that's our first file we created, and there are 2 more files. Now heading to the next one, which will be product underscore perf performance underscore df equals, say, silver df dot group by product category. So we are grouping by product category, and then aggregate of round of sum Now, what I did here is I grouped by product category this time because this is going to be the product performance metrics data frame. So I grouped by product category. For every product category, I added the total amount. I summed up the total amount and aliased as category revenue, and then the sum of quantity, and say total units sold for that category. And then because we need to see what are the overperforming categories and the underperforming categories with these metrics. And then count of transaction ID, which is the order count of that particular category. That is our second data frame. Now write that as well as a Parquet file. Dot write dot mode of overwrite dot Parquet. Now copy the same path that I used before, which is this one up to here, not here. Paste it and say product category performance dot Parquet. Run it. That will create another file. Let's check that out. Product category right here. We have another Parquet file created. Now last file for the regional sales. I'm gonna name it city revenue df silver df dot group by state dot agg. And alias it with city revenue. I did do the order count already before, but this time we are grouping by city, so that's going to be different. Round off avg amount comma 2 dot alias of avg underscore order underscore value. Close that with double parentheses. Okay, we did got an error. So it says round. Okay, I spelled it wrong. So I have to do the same thing. Copy that, paste it here. So change that to round. Move this dots. Run it. Okay, we did got another error. Okay, I spelled the transaction ID wrong. Let's fix that. Copy that again, paste it, run it. Now that is fixed. Oh, but I saved it as ITY revenue, not CD revenue. So I'm going to run that again because I just ran it for this variable ITI revenue DF, but I need CD revenue DF. Okay, now this is fine. Now write that into a Parquet file. CD revenue DF. No. Dot write dot mode of overwrite dot Parquet of codes, and I'm gonna copy the same path till this one, paste it, and say city revenue matrix dot Parquet. Run that, and now that will create another Parquet file. Now we have all the files that we need, which means we are done with the goal stage as well. We have the data with us. We have the business ready data with us. The only step left is the Power BI dashboard creation. Now let's head to that. So I'm going to show you how to connect Power BI to Parquet files and then work on them. Okay, we're almost done. Let's head to Power BI desktop. If you haven't, most of the people do know what Power BI is, but for the people who don't know, you can just download it from the Microsoft Store or from any web browser. It is free, and I will also provide the download link in the description. You can click on it as well. Now click on the get data from another source and choose Parquet from the list. Connect. Now here, this will be the interface you will be facing. It asks for the URL. It don't let you choose the path where you save the files at, but what you can do is you can just there you go. So you just extend this. You just need the Parquet file, not the CRC files. Remember that. Now first, let's start with our daily sales metrics Parquet. For that Parquet file, right click on it. Even on your file manager, do the same thing. Right click on it. You will see an option called copy path. Click on copy path. Go to Power BI. Control V. Now you will see the path pasted here, the whole path. Now click on OK. There you go. Now we have all the data that we need. Now click on load. After you confirm everything's perfect, click on load. Now we have one Parquet file here. We need the other two as well. So click on get data, drop down. I don't think we can find the Parquet option here. So click on more, click on Parquet again. Now copy the file path of the other two files that are left. First, the product category, copy path, head back to Power BI, paste the URL, click OK, load. The same thing with the other one, which is city revenue matrix. Right click, copy path, Power BI, get data, more, Parquet. Paste it, hit OK, and load data. Now we have all the data that we need, all the three files, the data files that we need are right here. Let me extend all of them, and The final outcome we expected include what? From the first one, which is this one, this is our first table that we created. We need the business growth, which includes the total revenue. So I'm going to click on the total revenue. Now, we need to create a card first. Create a card, hit on total revenue. This will show the total revenue. And then another card. Right next to that, and that will show average order value. By the way, when you hit on average order value, this will not show the average order value. This will be the total of all the columns in the average order value. To get the average order, you have to click on this drop down right here in the fields, and then switch the parameter of aggregation from sum to average. This is the average order value, 1.62K. That is it. And one more thing, we have to create a line chart. So click on the line chart. Now click on order date and total orders. Say total revenue. Okay. And then let me just minimize this. And to our next table, the next dataset we have, which is the category right here from this. And then we create a bar chart. Click on that and product category on x-axis and category revenue on y-axis. This will show the overperforming category and the underperforming category. And now with our last file, we can do a map chart by selecting city and the city revenue like that, or city with city order count. City order count. Can do that. If the difference is not that visible, actually, you can just go to here, format visual bubbles, and then for colors, click on effects, gradient, select the value as sum of order count. Here, first let me just click OK. Now this color difference is a good way to see the difference between the number of orders received from each of the cities. The darkest one has more orders and the light one has less orders, which is this. So this is a good chart. Let me just minimize that a little bit like that. And one more map chart should be fine. One more map. This time let's use the state, and then we used order count here. Let's use city revenue here. This is also looking good. Let's just format the bubbles like we did in the other map chart. Gradient. Okay. That's it. We can add a few more KPIs if you want. And basically, but the main goal of this project is to actually create a dashboard to show the visuals, but not decorating it in the good way. Because this is a data engineering project, we are not going to move forward and decorating this dashboard, but you can decorate it on your own. You can use your creativity to decorate it, and the sky is your limit. That being said, we have done with the whole project. We completed the whole project officially. Let's have a recap of what we actually did. We got the data source from a Python code, which is a fake data that we created with while ingesting wantedly the fault data into the actual data, and we created a CSV file. Then we pulled the data out of the CSV file using PySpark and assigned a schema to it, and then stored in the bronze layer. Then pulled the data out of the bronze layer, cleaned it in the silver layer, and then stored it in that silver layer. And after, in the stage 3, we pulled out the data from the silver layer and then made it business ready, and then stored it in the bronze layer with three separate Parquet files. At last, we connected all those Parquet files to Power BI and then created a dashboard. Well, it's not that good looking, but like I said, you can decorate it as you want. Let me go back. And that's it. Like I said, this project, the main goal of this project is basically to focus on PySpark, because this is a follow-up for my last PySpark masterclass. And I hope you like the project. If you do, don't forget to subscribe. If you share this to your friends, that will be appreciated as well. That being said, I will meet you again with another video, probably a masterclass. Until then, adios.